Welcome to Quantitative Aptitude session on numbers. In this part 1 video, we will focus on numerals, place value, face value and types of numbers. Let's get started. Let's start with numerals. To represent any number, we are using digits and the digits are from 0 to 9. To create a numeral, we are grouping up the digits. This is an example of a numeral and it is made up of the digits 938745 Let's see the expansion of this numeral. Here 8 is in the place of units and 1 is in the place of tens, 3 is in the place of hundreds, 5 is in the place of thousands, 4 is in the place of 10,000s, 7 is in the place of lakh, 8 is in the place of 10 lakh, 3 is in the place of crores and 9 is in the place of 10 crores. Next, we will see about place value. Place value is also known as local value. Let's see with an example. We are taking a numeral 938745318. Let's see the place value of each digits in this numeral. Here the place value of 8 is 8. Why? Because 8 is in the place of unit. So we are multiplying 8 by 1. So the place value of 8 is 8. Similarly, the place value of 1 is 10 because 1 is in the place of tens and we are multiplying 1 by 10 which gives 10 as an answer. So here the place value of 1 is 10. And similarly, the place value of 3 is 300 because 3 is in the place of hundreds and place value of 5 is 5000 because 5 is in the place of 1000. So we are multiplying 1000 by 5 and place value of 4 is 40,000 because it is in the place of 10,000 and we are multiplying 4 by 10,000 and the place value of 7 is 7 lakh because 7 is in the place of lakhs and we are multiplying 7 by 1 lakh which gives 7 lakhs as the answer. So the place value of 7 is 7 lakh and the place value of 8 is 80 lakh because 8 is in the place of 10 lakhs and we are multiplying 8 by 10 lakhs which gives 80 lakh and similarly the place value of 3 is 3 crores and the place value of 9 is 90 crores. This is how we have to calculate the place value of any digits in a numeral. Okay, let's see about face value. Face value of any digit in a numeral is the value of the digit itself. For example, consider a numeral which is 938745318. We are going to calculate the face value of each digit in this numeral. So here the face value of 8 is 8 because the face value of any digit in the numeral is the value of digit itself. Here the value of the digit is 8. So the face value of 8 is 8. Likewise, the face value of 1 is 1 and the face value of 3 is 3. Face value of 5 is 5 and likewise it will go on. This is how we have to calculate face value. Let's start solving the problem. I am reading the problem statement. The difference between the local value and face value of 7 in the numeral 657903 is, and the options are 0, 7896, 6993 and 903. Let's find the solution. As per the problem statement, they are asking the difference of the local value of 7 and the face value of 7 in the given numeral. So for that, we have to first find the local value of 7 and then we have to find the face value of 7. Then we have to find the difference between the two values. So here the local value of 7 is 7000 because in the numeral 657903, 7 is in the place of thousands. So we are multiplying 7 by 1000 which gives 7000. So the local value of 7 is 7000. And then we are finding the face value of 7. As we know, face value is the value of digit itself in the numeral. So the face value of 7 is 7 itself. Next, to find the difference between these two values, we are taking the difference. of 7007, which gives 6993 as the answer. So the option is C. Let's see the next problem. The difference between the place values of 7 and 3 in the number 527435 is. And the options are 4, 5, 45, 6970. Let's see the solution. We have to find the difference between the place values of 7 and 3. So for that we have to first find the place value of 7. The given numeral is 527435. So the place value of 7 is 7000 because 7 is in the place of thousands and we are multiplying 7 by 1000, which gives 7000 as the answer. And the place value of 3 is 30 because 3 is in the place of tens and we are multiplying 3 by 10, which gives 30 as the answer. And we are taking the difference of these two place values. So 7000 minus 30, which gives 6970. So the option is D. That's all about place value and face value. Next, we will see about types of numbers. First, we will start with natural numbers. All the counting numbers are called natural numbers. And the counting numbers are 1, 2, 3, 4, 5, and it will go on up to infinity. So the natural numbers will start from 1 and it will go up to infinity. Next, we will see about whole numbers. All the counting numbers together with 0 forms the set of whole numbers. Like the whole number is made up of the counting numbers together with 0. Like the natural numbers together with 0 forms the set of whole numbers. There are some of the points to remember. That is, every natural number is a whole number because all the counting numbers together with 0 forms a set of whole numbers. That's why every natural number is considered as a whole number. And 0 is not a natural number. Here the natural numbers will start with 1 and it will go up to infinity. So 0 is not a natural number. Next we will see about integers. All the natural numbers and the 0 and all the negatives of the counting numbers together forms the integers. We know from 1 to infinity it is a natural numbers and together with 0 it forms the whole numbers. And whole numbers along with all the negatives of the counting numbers forms the integers. Let's see about types of integers. We have three types of integers: positive integers, negative integers, and non-positive and non-negative integers. The values from 1 up to infinity are considered as the positive integers, and the values from -1 to minus infinity are considered as the negative integers, and 0 is considered as a non-positive and non-negative integers. So here all the natural numbers are positive integers. And we can say the positive integer as non-negative integers also. And we can also say the negative integers as non-positive integers. So these are all the three types of integers. Next we will see about even numbers. A number divisible by 2 is called an even number. Divisible is like when a number is divided by another number, if we get 0 as a remainder, that is called divisibility. We will see the divisibility in the upcoming session in detail. And as of now, if a number is divided by 2 and if we get 0 as a remainder, then it is called an even number. So the examples of even numbers are 2, 4, 6, 8, 10. When we divide 2 by 2, then we will get 0 as a remainder. Similarly, when we divide 4, 6, 8, 10 by 2, we will get remainder as 0. So these are all even numbers. And add numbers are when a number is divided by 2, we will not get remainder as 0. That is, it is not divisible by 2. That is called odd number. And the examples of odd numbers are 1, 3, 5, 7, 9, 11. When you divide 3 by 2, we will not get 0 as a remainder. That's why it is called as odd number. Next we will see about prime numbers. A number greater than 1 is called a prime number if it has exactly two factors, namely 1 and the number itself. For example, a number is said to be a prime number if it is having only two factors, namely 1 and the number itself. For example, 2 is a prime number when you divide and the 2 is having only two factors, namely 1 and 2. Likewise, 3 is also a prime number and it is also having only two factors, namely 1 and 3. So a number which is it should be greater than 1 and it should have exactly two factors, namely 1 and the number itself. So that is called prime numbers. And this is the list of prime numbers up to 100. We have already seen the list of prime numbers up to 100. Now we will see for the numbers greater than 100 how to find whether the given number is the prime number or not. Let's take an example. We have to find whether 191 is a prime number or not. As a first step, we have to find a number which is closest to the square root of the given number. So 14 is very closest to the square root of 191. And the second step is we have to list the prime numbers less than this closest number. So here the closest number is 14 and we are listing all the prime numbers which are less than 14. So the prime numbers are 2, 3, 5, 7, 11, 13. And we have to find whether 191 is getting divisible by any of the given listed prime numbers. So here 191 is not divided by 2, 3, 5, 7, 11 and 13. Like it is not divisible by any of the listed prime numbers. So 191 is not a prime number. If 191 is getting divisible by at least any one of the given listed prime numbers, it is then 191 will not be a prime number. But in our case, 191 is not getting divisible by any of the listed prime numbers. So 191 is the prime number. So to find whether the prime number is whether the given number is a prime number or not, which is greater than 0, we have to first find the closest value of the square root of the given number. Then we have to list the prime numbers which are less than the closest value, and we have to check whether the given number is getting divisible by any of the listed prime numbers. If it is not divisible by any of them, then the given number is a prime number. Otherwise, it is not a prime number. This is how we have to calculate whether a given number is prime number or not, which is greater than 100. Next, we will see about composite numbers. Numbers greater than 1, which are not prime, are known as composite numbers. Like the non-prime numbers are called composite numbers. For example, 2 and 3 are prime numbers, but 4 is not a prime number because it is getting divisible by 2 also. So 4 is a non-prime number which is called a composite number. Similarly, 6 is not a prime number, 8 is not a prime number, 10 and 12 are also not a prime numbers. So these are all called composite numbers. So the numbers greater than 1 and it should not be a prime number. Those numbers are composite numbers. We have some points to remember. Here, 1 is not coming under prime number and composite number. That means 1 is neither a prime number nor a composite number. And 2 is the only even number that is prime because the even number after 2 or 4, 6, 8, 10, 12. So, but these will be getting divisible by 2. So, we can clearly say that 2 is the only even number that is the prime number. And we can also say there are 25 prime numbers between 1 and 100. Next, we will see about co-primes. Two numbers are said to be co-primes if their HCF is 1. For example, 2 and 3. Here we are taking HCF of 2 and 3. The HCF of 2 and 3 will be 1. So it is called as co-primes. We will see HCF and LCM, those kind of things in the upcoming sessions. Now, as of now, you can understand like two numbers are said to be co-primes if then their HCF should be 1. So these are all the examples of co-primes. For the types of integers, we will see how to solve the problems. The problem statement is the least the prime number is, and the options are 0, 1, 2 and 3. Let's see the solution. Next, we will start with 1. We know 1 is not a prime number and not a composite number. So this is wrong, and we will consider 2. The least prime number is 2. 2, we can clearly say 2 is a prime number. So the option is C. The least prime number is 2. Let's see second problem. What is the total number of prime numbers less than 70? And the options are 17, 18, 19 and 20. Let's see the solution. To find the count of the prime numbers less than 70, first we have to list all the prime numbers less than 70. So the prime numbers less than 70 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61 and 67. So the total count is 19. That's why the option is C. Let's solve the next problem. The total number of even prime numbers is, options are 0, 1, 2, none of this. We know that 2 is the only even number which is the prime number. That means the count is 1. So the option is B. Let's jump into the next problem. Find the sum of prime numbers lying between 60 and 75. Options are 199, 201, 211, 272. So we have to find the sum of prime numbers which is between 60 and 75. So as a first step, we have to find the prime numbers between 60 and 75. So the prime numbers between 60 and 75 are 61, 67, 71 and 73. And then we have to find the sum of these prime numbers. The sum will be coming as 272, so that the option is D. Till now we have solved many problems and this is the exercise problem for you. Please try to solve it by yourself and we will see the solution in the upcoming video. I'll read the problem statement. The smallest 3-digit prime number is 103, 107, 109 and none of this. Out of this you have to find the smallest 3-digit prime number. So please try to solve it. And there is one more exercise problem for you, which is, which of the following is not a prime number? Options are 241, 337, 391 and 571. Out of this you have to find which is not a prime number. And please try to solve it by yourself. We will see the solution in the upcoming video. If you found this video helpful, please like, share and comment this video. If you want to stay up to date with our latest content, please subscribe to my channel, Spider Tech Hub. Thank you.